Hello, Mrs. Hoekstra here. We are in Module 3, Lesson 3, Writing Products as Sums and Sums as Products. I'm on page 17 of our book. You will notice the essential question is already up, and I have on there, what methods can you use to write products as sums? What methods can you use to write products as sums? All right, opening exercise. Solve the problem using a tape diagram. Those of us who are visual learners like these. A sum of money was shared between George and Brian in a ratio of 3 to 4. If the sum of money was $56, how much did George get? Right? So we've got George and Brian. I want to know how much George has. I don't care about how much Brian has, but it's in a ratio of 3 to 4, and it's a total of $56. All right, so there's all of our great pieces of information that we need. So there's two different ways we could make our tape diagram. One way is to look at this and go, okay, 3 to 4, that's actually 7 pieces, right? 3 go to George and 4 go to Brian. Did I do that right? Yeah. So what we're going to do is we can split this into our pieces, okay? And we can break this into 7 parts. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Yeah, the 7th one's a little big. Okay, and we need to know how much each of them gets, right? And since it's written in George to Brian ratio, right, it was given to me in that information, so George is the 3 and Brian is the 4. So what we can do is we can write George gets these 3, Brian gets these 4. Okay? And we know that it's a grand total of 56, right? This whole thing is $56. So in other words, what's 56 divided by 7, right? So this one is $8, $8, 8, 8, 8, 8, and 8, right? $8 in each one of those. And I want to know how much George got. George has 3 of them at 8, and 3 times 8 is $24. So George gets $24. You could make your tape diagram slightly differently. You could have made it so that you split George into 3, because that's literally 3, and then you could do Brian and split Brian into 4, right? You could set it up that way, where you have George and Brian, and then you could say 8, 8, 8, and another set of 8s, right? Because this one here is George, this one here is Brian, and then you could be like, oh yeah, that's 24. Okay, so that's how we could set those up. Either one of those would be perfectly fine. However your brain sees it, go for it. Well, what we're talking about is the distributive property, okay? We're going to learn different ways to rewrite this. All right, so step 1, or example 1 here, says just represent 3 plus 2 using a tape diagram. So I could do 3, right? 1, 2, 3, plus 2 for a grand total of 5, right? 3 plus 2 equals 5, right? And I have 5 in that whole tape diagram. You're like, yeah, I get it, piece of cake. Okay, well, let's change the 3 now to an X. We don't know what it is, okay? I don't know this piece. It could be however big or small. I don't know how big that is. And then I'm going to add 2, right? 1, 2. So how would that look? Well, it's going to look just like we did a minute ago. Unfortunately, since I don't know what X is, it is literally X plus 2. Okay, that is the answer. I am done. I have my strip that is X. I have my 2 little pieces that are each 1. Until I know what X is, X plus 2 is all the further I can go with that. All right, now it says to draw a rectangular array for 3 plus 2, but I'm multiplying it by 3. So I'm going to take my 3 plus 2, 3 plus 2 more, right? There's 3 plus 2 from up above, and it says I need to do this how many times? I'm going to do this 3 times. Okay, so I'm going to have it 3 of them. And 1 more set, right? And 1 more set. So let's see here. This was, right? This is 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6, right? This is really 3 sets, right, of 3 plus 2. So if I go through this whole thing, right, if I count that all up, I have a grand total. This whole thing is equal to 15. If I count up all those little ones, right, it equals 15. I have 15 of them in there. Okay, and instead of writing all those single little ones, if you wanted, oh, my eraser's a little bit big, but I'll make it work. Instead, I could write it as 3, 3, and 3, and then same thing with the other ones. I could make this a little bit smaller, right? I could make this so that it just says 2, 2, and 2. Okay, either way, I'm still going to get the same answer. So in other words, 3 times 3 plus 2 is equal to 15. And we'll get more into this as we go along. All right, page 18. Go to page 18. Top of the page says draw a rectangular array for 3 times x plus 2, just like we did a second ago. So I've got my x plus 2, right? I don't know what x is, plus the 2, and I need how many of them? I need 3. Okay, I'm going to get 3 of those. I'm not very good at keeping them all the same size, but I think you guys can figure it out. If you're working in 2 colors, this would be great. So I have x and x and x, and 2, 2, and 2. Sure enough, I have 3 of them, right? I've got 3 of those. 3 what's? I have 3 x plus 2's. Okay, I don't know what this equals, but I could kind of figure it out. How many x's do I have? I've got 1, 2, I have 3 of the x's, plus, now I can add up 2, 4, 6. I can add that up, okay? So that's kind of a piece of cake. I could also draw it one other way I want to show you. I could draw the x's all as one great big. There's 3 of the x's, and I could just write in 3x. And then I could do the same thing with the 2's, right? 3 times 2. Think of this as like, you know, find an area of a rectangle, right? This rectangle right here, this length here is 3 times 2. 3 times 2, that area there is 6. And I could just put a 6 in there. Okay, so I want you guys to look at exercise 1. I want you to do this one on your own. Hit pause. Figure out what those 2 blanks have to be. Kind of like I just did a second ago up here, where I figured out what had to be inside there. I want you to do that right now. Hit pause. See if you can figure out what the answer is for those areas. Okay, so here's what I have. I did 11 times 16 for the big space, and 11 times 16 is 176. And then the other side was 11 times 5, which was 55. So in other words, this whole rectangle, the length 11 times the width, which is 16 plus 5, right? I can think of this as 16 plus 5. Here's our width, and this is our length. All I'm doing is length times width, like you would if you were finding an area of a rectangle. Well, 176 plus 55, 231. All right, well, let's change it up just a little bit. Let's go to example 2. Draw a tape diagram to represent each of these expressions. Okay, so there's a couple different ways we can write these. So I'm going to start off with x. I have no idea how big x is. X plus y. They could be the same, they might be different. And I'm going to add to it x and another y. And lastly, another x and another y. Now, if you are working in 2 colors, that would be helpful. If you have a highlighter, you might want to highlight which ones are the x's and which ones are the y's so that they kind of stand out at you. Well, I could take those x plus y's from up here and rearrange them. Use the commutative property, right? Rearrange them so that the x's are all together, right? Where I have x plus x plus x, and then I could do y plus y plus y, right? And notice they're the same length as the one above it. Look at that. Okay, this is what is called the expanded form. Expanded form. You know why it's called expanded? Because it's really big, it's wide, right? It takes up a lot of space. Literally x plus x plus x plus y plus plus y plus y. Those are, the longest way we could possibly get there. Versus 3x plus 3y. If you notice, 3x plus 3y is going to look the same way. There's 3x, here's 3y's, right? 3x plus 3y. Okay, 3x plus 3y, written this way, even though the tape diagrams are identical, okay, this one is called the standard form. Because now all I have to do is do 3 times x and 3 times y, whatever those variables are when I tell you what they are. Okay, so standard form and expanded form are the same, going to give you the same answer, but they're going to be written differently. All right, some of you like the expanded form because it's one that makes the most sense to you, but the standard form is where we kind of really need to be headed, okay? So kind of get your brain to start understanding that x plus x plus x is just literally 3x, okay? Because I literally counted 1, 2, 3 of them. Okay, then we have this other one here. This last one here says that I am going to take and I'm going to have 3 x plus y's, right? Here is an x plus y from above that we keep doing, right? X plus y, and I need 3 of them. So I'm going to do them this way instead. I'm going to go vertically, and it's still going to give me the same answer, okay? And I have 3 x plus y's. All right, 3 x plus y's. I've got 3 of them. That is an x plus y going across the bottom. Okay, or you could draw this as one rectangle and then the other one next to it. Okay, so that we have our x plus y across the bottom or across the top if you want to write it up there, and then I still have my 3 there. So this would be 3 times x or 3x and 3 times y. Just length times width of each of those 2 separate rectangles. Honestly, this is where we want to head. Okay, if you need to draw the other one, that's fine, but this is the one that we're kind of headed to. All right. So, example 3. Find an expression by modeling with a rectangular array and applying the distributive property to the expression 5 times 8x plus 3. Okay, so I'm going to do it in the second method that I just showed you. All right, so I'm going to draw myself a rectangle with a piece added on because I know that I've got this addition. The 5, I'm going to make be my side over here. You know what, just to make it easy, I'm going to just draw this one up here. I'm going to write 8x up here plus 3 across the top, 8x plus 3. Okay, just so you guys can see where everything goes. This is that second number. All right, so ultimately, this space here is 5 times 8x. Well, we've done this before. What's 5 times 8? Well, this is 40. So this is 40x. The next piece over is 5 times 3. Okay, 5 times 3, easy enough, that's 15. So what we're learning and discovering is that 5 times 8x plus 3, we know that it is equal to 40x plus 15. Again, if you're working in highlighter, maybe you highlight the 40x one color and the 15 another, and then highlight it in the answer as well. That you are highlighting the stuff that I am color coding so that you can understand where the numbers are coming from. Or if you need to, just draw arrows. Do something in your notes to make it so that you understand where these numbers are coming from. All right, let's try 2A together. 2A, we're going to do this one together. For parts A and B, draw an array like we just did and apply the distributive property to expand each expression and then substitute it in just to prove that they're equal. So what we're going to do, we're going to start off by drawing 2 times what? X plus 1, right? So this is just 2 times x or 2x, and the other place is 2 times 1, which is 2. Okay? Now it says plug in the number 5 and see if it really works. So we're going to take the number 2 times, we're going to plug in 5 plus 1 in the original problem. Right? I'm doing the original problem. And 2 times 5 plus 1, which is 6. And 2 times 6 is 12. Or I can do this blue one here that I have inside. I'm going to take that one and do it over here. So 2 times 5 plus 2, right? I'm just going to take what I have inside, and I'm going to end up with what? 10 plus 2? And 10 plus 2 is 12. Sure enough, these are equal to each other, right? They're equivalent. Yay, we must have done it right. What I want you to do is hit pause. I want you guys to do B, just like I've done the last couple examples. Okay, give it a shot. Do it on your own. Hit pause. Okay, well, when I worked it out, I got my first rectangle to be 20C and my second one to be 50. And then when I plugged in the number 1 into both the original equation and my new one, 20C plus 50, I got an answer of 70. If you didn't get that, go ahead, hit pause, fix it up, get it right. All right, and on the other hand, I'm going to head to letter C. Okay, so for letter C, it says, again, apply the distributive property and substitute the given values. So this time, instead of drawing it out, I'm going to do some of the math here. Now, if you haven't caught on, what I've been doing is just multiplying this first number, right, by everything on the inside. Okay, just multiplying that first number by everything on the inside. So make those little rainbow things. Every time you touch one of those numbers, you're going to get this to work. So I'm going to do 3 times 4F. I'm going to put in the minus because there's that subtraction sign there, right? Or you could smatto it first if you want. And then 3 times 1. Okay? So I'm going to plug that in, see what we get. So 3 times 4, this is 12F, minus 3 times 1, which is just 3. Now it says substitute in my number to see if I get an equivalent answer. So I will take the original and do the original first. So 3 times 4 times, what is it, 2 minus 1. So 3 times 4 times 2 is 8 minus 1, which is 7. So really I have 3 times 7, and 3 times 7 we all know is 21. All right, let's try it with my new and improved one, this one that I have here in green. I'm going to put a puffy cloud around it. I'm going to do that one now. So 12 times 2 minus 3. Well, 12 times 2, I know that that is 24. Minus 3, 24 minus 3 is 21. Look how much shorter that was. That was one whole step shorter, right? A little bit faster. By having it simplified, it's a little bit faster. What I want you to do is I want you to hit pause, and I would like you to try D. Okay, well, there is all my work. I multiplied, distributed that out, right? And I got negative 27R minus 99. And then I just plugged in my 10 into both the original equation I was given in part D and the new one that I made, and I found that the answers were the same. If you worked it out and your answers were not the same, try to figure out where your error was. Okay, it may have been way back at the beginning with the distributive property, or it could have even been just plugging in and not maybe multiplying correctly or not subtracting correctly. All right, I'm going to page 20. If you need to hit pause right now and fix this, go ahead. Top of page 20, we are going to write the expression. This time, notice though, instead of multiplying, I am dividing. And if you remember, we talked about that dividing is the same as, multiplying by the reciprocal. Right? Multiplicative, what was the crazy word? Multiplicative inverse. That's the key that we want to remember, the multiplicative inverse. So I'm going to take, oh, there's a little typo in there, isn't there? We need a little parenthesis in front of that. So we have 6x plus 15 divided by 3. So 6x plus 15, put it in all parentheses, divided by 3. But I cannot divide, so I'm going to rewrite this as 6x plus 15, still in the parentheses, but I'm going to multiply it by the multiplicative inverse, 1/3, right? Because I know that 3 has a reciprocal of 1/3. Okay, because this is 3 over 1, flip it, becomes 1/3. Okay, now I can use the distributive property. Distribute the 1/3 to the 15 and distribute the 1/3 to the 6x. So 6x times 1/3 plus 15 times the 1/3. Again, I'm using multiple colors, maybe highlighting so you guys can see where these are all jumping out at you. It's really important to get this so you understand how it all works. Well, 6x I can put over 1, and then I can cross reduce. 3 goes into itself once and into 6 twice, so that just becomes 2x plus, and again, I can put 15 over 1, and I can cross reduce. 3 goes into itself once and into 15 5 times, and so that just becomes plain old everyday 5. So that whole thing ends up just being 2x plus 5. We're not going to plug anything in, see if it works, anything like that. We're going to trust that I did it right. All right, exercise 3. Let's try this one. First of all, notice we're dividing by 2. So what is the multiplicative inverse of dividing by 2? We're going to multiply by half. So let's start off with 2b plus 12 times 1/2. Again, highlight it, do it in a different color, do something so it jumps out at you. Okay, distribute 2b times 1/2 plus 12 times 1/2. Okay, well, what's half of 2? Half of 2 is 1, so this is 1b, or just b. And then what's half of 12? Half of 12 is 6. So you could write this as 1b plus 6 or just b plus 6. That's the one I like better because it takes a lot of work to write that 1. All right, I would like you to hit pause and try the next 2. Okay, I want you to do the next 2 on your own. Hit pause. All right, check your answers with mine, see how you did. If you have some mistakes, fix them, or come into class ready to ask me, hey, how'd you get those? All right, I'm going to move on. Top of page 21. Okay, top of page 21. Really quickly, we're going to expand. You can do this with more than just 2 numbers. Okay, so we're going to take 4 and we're going to multiply it by x plus 4 times y plus 4 times z. 4 times z. Okay? And so when you do that, you actually just end up with what? 4x plus 4y plus 4z. I cannot combine those. All right, even though they all have multiples of 4, they don't all have the same variable with the same exponent or the same power. So that is all the further that goes. But you can expand it to more than just the 2 numbers. All right, so we're going to do the same thing. I'm going to draw it out this time, though. So we have 3 times x plus 2y plus 5z. And let's draw this out. Okay, so here's my 3. We'll just put this into 3 parts, right? We're going to put the x here, we'll put the 2y at the top, and we'll put the 5z in the last spot, right? Just put each one. You can even put the little operations. I like to put the operations on the lines there, so that it makes it easy for me. All right, so this is just 3 times x, also known as 3x. The next spot over is 3 times 2y. Well, 3 times 2 is 6, so that becomes 6y. And then the last spot is 3 times 5z. Well, 3 times 5 is 15z. So what does this end up equaling? This ends up equaling 3x plus 6y plus 15z. Okay? All right, last page, last problem. Here we go. I know this has been a long one, guys. Top of page 22, last problem. A square fountain area with a side length of S feet is bordered by a single row of square tiles as shown. Okay, I don't know how long this is. Notice it says S, but I do know one tile is 1 foot by 1 foot. In other words, right here is a 1 foot by 1 foot tile. I do not know, however, how long this part is. Okay, I have no idea, so they called that S. S for side, probably. Okay, so what we're going to do is we're going to find different ways of rewriting it. It says 3 different ways to write this exact same problem. So one way I could look at it, okay, now there's going to be multiple drawings on here. Let's go with the one I've already started here on the right-hand side. So I know I've got one here. I've got this whole section here that I just called up to there. I called that S, right? And then, so this entire side from here, from the top to where I just stopped scribbling, right, that is S plus 1. Right? Could I do the exact same type of thing here where I have my S across the bottom plus the 1 square in the bottom there, right? I could do that. How many times could I do that particular design? If you need to, let's draw it out. So you know what? Let's draw it out. So this is S plus 1 because I got that 1 right there, right? There's S plus 1. I could draw another line here. This side here is also S plus 1, and across the top is S. Across the top here is S plus the 1. How many S plus 1s do I have? I've got 4 of them. 4 S plus 1s. Okay, that's one way I could write it. All right, I'm going to erase the majority of what we just did. I do want to leave that S plus 1 there for you so you can see it though. Another way I could look at it, I'm going to use a different color, is I've got that 1 up here, right? And I could do that for all of the corners, right? I could say all of those are 1s. So I have how many of those? I have 4 of those, right? 1, 2, 3, 4. I've got 4 of those. 1 plus 1 plus 1 plus 1. And then each of the spots in between are all what? S's, right? Plus S, plus S, plus S, plus S. Okay, that's the expanded form, right? That's the full, all the way out expanded form. So there's a second one. Okay, so the first one uses the distributive property. The second one shows the expanded form. Now let's just take the expanded form and rewrite it. How else could I write 1 plus 1 plus 1 plus 1? 4, right? How else could I write S plus S plus S plus S? Well, how many do I have? I have 4 of them. And if you want, you could rewrite it as 4S plus 4. Just use the commutative property. It's the same thing, and it's all good. So how many do I have? I've got 1 here. I've got a second one here, and I have a third one down here, either one. Okay, either way, I've got 3 of them there. Awesome. All right, that is all. If you've got questions, this is slightly confusing. Sorry about that. And I will gladly answer any questions that you have for me in class.